Welcome to part 2 of the Metal Building Manufacturers Association presentation series on fire resistance design for metal building systems. This part is on the basics of fire resistance rated assemblies. My name is Nestor Ivancu. I am senior engineer at Jensen Hughes, and for the last 10 years have also served as the fire protection code consultant for MBMA. A short disclaimer: please note that while all of the information presented has been completed as accurately and completely as possible, it is basically limited to the 2009 IBC building code. Any applications for your local jurisdiction are subject to the responsible design professional and also the approval of the local authority having jurisdiction. Some fire resistance basics that will be used throughout the remaining parts of this presentation series. Even though steel as well as concrete and masonry are all identified and are non-combustible materials that don't ignite and burn, all materials, including the non-combustible ones, will degrade at high temperatures. This degradation can be of two forms. It's physically visible damage, such as cracking, buckling, loss of material, charring or an actual burning of wood and plastics. But also the mechanical properties deteriorate, and these are your strength and your stiffness, which are important for the structural performance. Higher material temperatures are directly proportional to this deterioration, both physically and in terms of mechanical properties. Hence, your fire resistance and your fire protection is intended to slow, retard the increase in the temperature of the construction material and thereby to minimize or mitigate the deterioration of its mechanical properties and its physical damage. One way to quantify the fire resistance of steel is this W/D parameter or ratio, and this is the ratio of the section lineal weight, so it's pounds per foot, and the denominator is the heated perimeter of the shape. In terms of protection, we can have what's called contour protection, which is applied around the profile of the shape itself, as you can see, and this is normally with your spray applied material or your intumescent coatings. For your gypsum board protection, it's as the name implies, this is box protection. You box around the section to enclose it in the gypsum board, and there geometrically the calculation for the heated perimeter is different than for the contour protection, especially with the round and the eye sections. Obviously for the square, the rectangular sections, those are identical, but for most of the other shapes, the box protection and the contour protection, the heated perimeter is different numerically. The types of fire protection materials, there are membrane protection and the gypsum board. Gypsum board is the material of choice for metal building systems and has been for all of these decades, and the reason is both the efficiency and the performance of the material fits the needs. And also, in addition to being fire protection material, gypsum board is a architectural finish product, so you get the nice finished look as well as the fire protection with gypsum board. Spray applied fire protection is very common and popular with the heavier steel construction, multi-story steel. That is most common there. Intumescent and mastic coatings are very architecturally appealing and are used with architecturally exposed steel. Usually for metal buildings, single story, they may be an overkill. They're quite expensive, and maybe for special situations there may be a need and a fit for it, but usually other types of fire protection materials will be preferred. Also, one of the original fire protection materials, concrete and masonry encasement of steel. That is the old form of steel construction. Typically now, because it is quite heavy and more expensive than membrane or spray applied, unless you really need it for fire separation walls, one prefers to use the lighter fire protection material rather than concrete or masonry. Now, as I mentioned, gypsum board is the material of choice for fire protection in single-story metal buildings. A word of caution, though, is that all gypsum board is not created alike. There are basically three classifications of board. Your lowest level is just generic unrated board. This is the type that maybe you find for residential unrated construction. You can buy at your local hardware store. And one would not use this for fire resistive construction. The minimum type of board that you need for rated assemblies are either Type X, what's called Type X, or enhanced Type X, which is also known as Type C, is even the best performing fire resistive board. In terms of substitutions or allowances, the UL assemblies or rated assemblies in general will specify the manufacturer and the type of board that is required for that particular assembly. Type C is the best board, the best performing board, and one could substitute Type C board for a Type X application, but not the other way around. And we have seen that in some situations where incorrectly Type X board has been used where Type C has been required, and that just doesn't work and is a rejectable issue. UL is one of the primary accredited labs that does fire resistive testing and issuance of these rated assemblies. They have a system for classifying the different types of construction and assemblies that they have, as well as the different types of protection. It's an alphanumeric system. Basically, the type of building construction element is the alphabetical part of the designation, the ABC, if you will, and then the numerical part of the designation designates what kind of protection, whether it's membrane, directly applied protection, spray-ons, or intumescence, or unprotected in some cases. And here you'll see in terms of metal buildings, because the focus is primarily on membrane protection, so gypsum boards or acoustical ceilings, and then we'll be primarily talking about roof ceilings, beams, and columns. So for roof ceiling assemblies, the alphabetical part of the designation is typically P. It could also be Q or R. And then for your acoustical exposed grid systems, you're talking about the 200 series, for gypsum board 500 series. So again, it would be a P200 or a P500 assembly that would be applicable. In terms of walls or partitions, they have the prefix of a U, V, or W. And for metal stud, gypsum board, lath, and or plaster, with the highlighted box, you're talking about the 400 series. So again, it would be a U400 or a V400 series that that would be of interest. For columns, the prefix is X, Y, or Z. And with gypsum board protection, we're talking about 500 type numbers up to 599. And we'll see some examples of all of these. Now, in terms of applying and understanding a UL design, these are governed by ASTM E119 or the equivalent UL 263. For Canada, there are equivalent Canadian standards that are basically quite similar. The rated assemblies are all rated to these standards. The listings give you all of the requirements, both in terms of installation requirements, in terms of design limits on minimum sizes, spans, if you will, or spacing of members, as well as the brand names, the types of products, proprietary products that that were tested and validated for use in that particular assembly. Any alternatives, alternates, and options that are approved are also given. So this is a very specific menu of items for each and every rated assembly that must be followed. Any substitutions must be one must be very careful with, because they may not be correct, and it's always subject to the discretion of the local building official. In certain cases, an independent engineering judgment evaluation may be necessary to approve a substitution. In addition to the assembly itself, UL has quite an extensive design information section in the front of all of its listings, and this has some very important background and basic information when one is dealing with the various topics. And often people do not look at these because it's not the assembly itself, but by reference it applies to all of these assemblies. So please be aware of this, and be aware that it is equally applicable as any individual assembly listing may be. The links to these sites and the ones that we will be given in the future will be given with your video notes. So let's look at one of the MBMA assemblies, developed assemblies, and this is one of the newer ones. It's UL Design W413. Let's recall what I mentioned about the UL alphanumeric system. So a W means a wall, and the 400 series was gypsum board protection. So again, this fits with the UL numbering system. And let's look at the actual link to W413. As an aside, UL annually publishes a multi-volume set of all of their listed assemblies, construction as well as joint and penetrations, etc. However, it's in the internet and digital age, it is now much more convenient to find these online, and UL has a nice online database as just illustrated. If we find the right link and go to the assembly itself, we can find the most current information, and frequently these assemblies may be updated during the year or several times during the year. So you will find the most current information online, and this can be used for your reference and for your project. So let's scroll down a little bit and see what this gives. So it gives you a non-load-bearing wall rating of 2 hours. It gives you a picture and then shows the various cross-sections. And here are all of the details in terms of the sizes, the requirements, etc., as well as the products that are listed for that particular assembly. The building codes, IBC recognizes and is very explicit in recognizing all fire resistive assemblies tested and verified via ASTM E119 or UL 263. UL designs in their fire resistance directory or listed online are all approved and may be referenced and used. Intertek, another well-known accredited lab, also has a number of assemblies that they have developed and published. So these are all viable, usable assemblies. The International Building Code also gives you a table, multi-page table, of what's called generic assemblies, or they're also the more of the archaic type of construction that sort of has been grandfathered in. So in some cases this table can be quite handy, and particularly with remediation of older buildings, if you will, in verifying, validating that a construction is of a certain fire resistance level. There are also in Chapter 7 other prescriptive IBC provisions that we'll get to later in these presentations. Certain product manufacturers also regularly issue and update what's called ICC evaluation reports. This is the sister organization to the IBC, and basically what they do is they conduct a peer review of submitted information by a client, a product manufacturer, and then they issue a nice compilation of this data that's been, again, peer reviewed and approved by the ICC service, International Code Committee. And that then is also an acceptable, a good reference to use for gaining acceptance of your construction with the local building jurisdiction. MBMA has sponsored a number of fire tests over the last 30 years, both at UL and FM Global on sprinklers. Building construction has been principally tested at UL, and this has been columns, interior and exterior walls, and roof ceilings, and more recently some joint assemblies. The items of interest that we will be highlighting and that have been directly sponsored by MBMA are these. So we have 3 column assemblies in the X series, 3 roof assemblies, 2 load-bearing walls, 4 non-load-bearing walls, and we have some of the more recent additions. We have head of wall joints, 3, and 3 wall continuity system joints. All of these are either 1 or 2 hour rated systems, which are the most commonly required ratings for metal building systems. If you go to the MBMA website, as we will soon do, you can find the listings and again get access to all of these many MBMA-sponsored UL assemblies. And here are the ones that I showed you just previously in terms of the ratings and the type of protection. But if we go to the link, we'll hook up to the MBMA website. Here it is. If we go to fire protection, which we're at, we can see all of these. And again, this table that we saw on the slide. And if we're interested in one of these, and let's bring up the W413 that we just showed you a while ago. If we punch on this, we can again reconnect with UL, and we'll get to their website and see the exact listing that we're interested in. So it's very convenient. If you go to the MBMA website, you scroll down, you find what you look, and then you can get connected to the actual listing on the UL site. In the Fire Resistance Design Guide publication that was published in 2010, we also included about 25 other types of assemblies not developed through MBMA and only referenced as a possible assembly of interest, an application that might fit with light frame construction metal buildings. Again, MBMA does not endorse any of these products or assemblies, but only provides them as additional possible information as any other assembly published by Intertech or UL would be. It's out there and it's fair game for use if it fits into your project. The main reason for publishing this is because in some cases the 16 or 18 MBMA sponsored assemblies just don't fit the particular building design, so some alternatives are needed. In particular, if one needs a heavy 3 or 4 hour fire separation wall, firewall, the best option may be concrete masonry or a heavier type of construction. And again, then you have to go to this inventory of other assemblies. And here's some more alternatives. This is all listed in the 2010 Fire Resistance Design Guide as, again, a design aid to shorten your search time if otherwise you do a search of the whole UL Fire Resistance Directory, which has hundreds of assemblies. So basically that concludes part 2 of this series. Thank you for your attention.